In this video, we're going to talk about some properties of the convergent series. They're pretty intuitive, but still worth mentioning. So if we have two convergent series, let's say series A sub n and then series B sub n, then those two series are, first of all, equal and also convergent. So if we take convergent series A sub n and multiply it by a constant, well, that series is convergent, and that constant can be also put in front of each term of the sequence here. So those two are equal and convergent. Now if we add two convergent series, each has a finite sum, well, their sum is also convergent series, and same goes with the difference. Now, depending on the situation, we can use those properties starting on the right-hand side or on the left-hand side. So it all depends. So let's use one example. In this example, we need to determine whether the series is convergent or divergent. And if it's convergent, we need to find its sum. And this is how we can approach it. Since general term represents a sum, what we can do, we can split it up. We can view this as two series. So the first one is series, and from 1 to infinity, of the negative 0.2 to the power n, and then plus another series, which is series of 0.6 to the power n minus 1. And if we find that both of them are convergent, then the original series is also convergent. Okay, so let's focus on each. So the first one is series of negative 0.2 to the power n. What kind of series is that? Well, that is the geometric series, right? We have a constant raised to the power involving n. Let's put this geometric series in standard form. Since n starts at 1, we want to have power n minus 1. So to create power n minus 1, I'll multiply by negative 0.2 to the power negative 1. Now, if I combine them, I'll get power n minus 1, but what I just multiplied by, I have to cancel. So to cancel that, I have to multiply by another negative 0.2 to the power 1 in this case. So minus 1, so I have power n minus 1, but then this power to cancel, to cancel this factor, right? So this is how the series is going to look like now. And from 1 to infinity, so I'll put this negative 0.2 factor in the front. And I will combine the powers for the first two factors. So it's negative 0.2 to the power n minus 1. Okay, so once I obtain power negative 1, now I can determine what is what there. So whatever is raised to the power negative 1 is the common ratio. Common ratio R. And that's the one that I need to use to determine if the series is convergent or divergent. Well, since it's between negative 1 and 1, that means that the series is convergent. Right? And since it's convergent, I can find its sum, and I do it by using the formula a over 1 minus r. So a. Now a is this number over here, that's the constant by which I'm multiplying common ratio with its power. So a is negative 0.2. This is a. And in the denominator, I'll put 1 minus r. 1 minus r. So 1 minus negative 0.2. Like that, right? That's the formula for finding the sum of the convergent geometric series. That's negative 0.2 over 1 plus 0.2, so it's 1.1. So to simplify this, I think I'll just switch to the fractions. This is 2/10, right? That's negative 2 over 10 divided by, this is 12/10. So it means that it's same as multiplied by 10 over 12. So 2/10 that is 12/10. Okay, and that means that the result here is -1/6, -1/6, right? That's the first part, this piece over here. And then now let's look at the second piece. That is series with n from 1 to infinity of 0.6 to the power n minus 1. Now I already have power that I need, so I don't need to do any adjustments here. So 0.6 is r. Since it's between -1 and 1, again, 0.6 is between -1 and 1. It means that the series is convergent. By the way, when I say that common ratio is between -1 and 1, it's the same thing as absolute value of the common ratio is less than 1, right? That's another way to say that, absolute value. Okay, so it's also convergent. So first of all, I can already say that the given series, this one, is convergent. So this one is convergent, and this one over here is convergent. So that means that this series is convergent. But if it's convergent, we need to find its sum. We already know the sum for the first piece here, that's -1/6. Let's find the second one. Okay, so the formula is A. Now what is A in this case? A should be the constant over here, which I don't see. It means it's 1. 1/1 minus R, 0.6. So it's 1/0.4. That is same as 1/4/10. So it's 10/4 or 5/2, right? So that means that I need to add 5/2. So we'll multiply by 3 on the top and on the bottom. That's going to be -1 plus 15, so 14. That is 14/6 or 7/3. So here's the conclusion for this example. This series is convergent and its sum is 7/3.